So we'll continue with example 7.2 namespaces with public and private variables. So here we define a variable again at the top with new weak map and a private method new weak map, and then we create class namespace, and then we use constructor. So we still use constructor to create an object for weak map. My private that said that these my private method that says this that my public equal foo, etc. Then a public function utilizing these privates. So my public function argument bar inside is with initialize a variable inside this object. Let private var equal my private var that get argument this closing next line const private method equal my private method that get argument this, then increment our private counter private var plus plus, then closing next line my private var that set argument this comma private var closing, then call our private method using bar private method argument bar. Another example of using this wake map is again we create now it's constant. Actually the first object, the example 7.2 is also a constant. So it's following the same pattern as the constructor above that we have discussed. So const basket equal new weak map for 7.3, const do something private equal new weak map again, then const do something as private equal new weak map. So basically we're creating this three parent prototype that will be referenced inside our public class. So here class basket module and then constructor again, since we copy the pattern that constructor does, basket that set this that set argument this comma empty array closing, the next line do something private that set argument this comma open and close parenthesis, next line do something as private that set argument this, and then public aliases to a private function do something open semicolon bracket inside do something private that get argument this closing, and then do something else inside open parenthesis do something else private that get argument this, and then add items to our baskets, add item argument values open semicolon bracket, next line const basket data equal basket that get argument this, next line basket data that push argument values closing, next line basket that set argument this comma basket data, then get count of items in the basket, get item count open semicolon bracket, next line return basket that get argument this that length, then get total values of items in the basket, get total open semi return basket, next line dot get argument this, next line dot reduce argument current sum comma item, then item dot price plus current sum comma 0. Why not just use a normal private field? Modern JS supports class module open semicolon bracket, inside is as hashtag counter equals 0 closing. That's cleaner. So weak map has historically used before weak map was historically used before private fields existed. So these private fields are actually the modern way we do the weak map. So we use this hashtag counter inside the module because again module can now support import and export. As you can see, these are more the old ways or the legacy ways to do or encapsulate a private method. Now wake map is mainly useful when you want privacy across instance externally. So outside of your instance of that object, you want still a privacy, kind of like double privacy, unlike with this private. But you don't actually, that's not actually practical or do not have use case in the real world. So that's what this means. You want memory safe metadata tracking. You are attaching hidden data to external objects. 6. How does this reduce complexity? Now we can connect to everything we discussed. Complexity increases when state leaks, objects can be mutated arbitrarily, internal state is visible, external code can corrupt invariance. So if that state leaks, meaning that state is meant for that object only at that particular time, and some objects are accidentally are able to, like, that state accidentally affect other objects, therefore you have state leaks. Objects can be mutated arbitrarily. You don't want an object to be changed arbitrarily, because somewhere in the code that would happen, especially if the code that you're written now or 6 months ago won't be remembered. So it's important for you to make sure that objects does not, as much as possible, do not mutate. Internal state is visible. So you don't want internal state, because that's another implementation versus interface. You don't want implementation to be shown. External code can corrupt invariants. So if you have invariants that do not change, you don't want external codes that accidentally change that principles that do not change. Weak map helps because private state cannot be accessed directly. No one can do module dot underscore counter equal 999. Invariants are protected. State is encapsulated. Encapsulation reduces cognitive load. So again, encapsulation is another way of saying that we need to separate implementation and interface. But I mean, it's part of that. But encapsulation, kind of like one case of using interface versus implementation. This connects directly to philosophy of software design. Ousterhout's principle, deep modules hide complexity. Weak map is a mechanism to hide state complexity. How does this connect to your fintech or retry question? Imagine this: you have payment retry class. You don't want retry that retry count equal 999. Then retry that status equals success, because that breaks invariant. So you don't want basically retrying it all at the same time success, because it defeats the purpose. The reason why you're retrying is because it did not success. It did not succeed. You want state transitions controlled. So you want that state transition controlled, meaning the invariant should never be changed. Like it is the main or the basic principle or the basic truths in your app. You don't want others to be able to change that. Internal counters hidden. Retry logic protected. Weak map can enforce that. So weak map can enforce this. Cons underscore retry count equal new weak map. Then we create class payment retry. Inside is a constructor. The next line underscore retry that count that set argument this comma 0. Then next line next method inside this class is increment. Then inside increment count equal underscore retry count that get argument this. Next line underscore retry count that set argument this comma count plus 1. Closing of this class. Now no external code can modify underscore retry count. You basically control the state transition. This protects invariance. So let's continue this why weak map exists beyond privacy tomorrow.